let's just jump right in. Think about this for a second. How do you make absolutely sure a self-driving car is safe? It's honestly one of the gnarliest engineering puzzles of our time. We're talking about technology that has to make literal life or death decisions in a blink of an eye. So how on earth do you test for every possibility before that car even thinks about hitting a real road?
And that really gets to the core of it, doesn't it? How do you put something as incredibly complex as, say, a Tesla full self-driving system through its paces, where one tiny mistake could be catastrophic, without putting anyone or anything in harm's way? Well, it turns out the answer isn't found on a test track.
You see, for the longest time, the fundamental problem has been this massive, high-stakes gamble. To find out where an autonomous system might fail, you literally have to push it into dangerous situations. But doing that with a human driver in a multi-million-dollar prototype? Yeah, that's just a recipe for disaster.
And when you really break it down, the challenges are huge. The physical risk to people and expensive gear, that's obvious. But what about the human factor? A human test driver can't slam the brakes at the exact same millisecond over and over. People get tired, they get distracted, and you can't just replicate some bizarre one-in-a-million edge case thousands of times on a real street. It's just not practical, safe, or even remotely affordable.
So if the old way is too slow, way too expensive, and just plain dangerous, what's the alternative? This is where we get to shift from the problem to a really fascinating AI-powered solution. Let's talk about a tool called ZAPTEST.
So what is ZAPTEST? To put it simply, think of it as a tool that creates a perfect digital copy, a digital twin, of a car's entire software brain. It's basically a virtual sandbox where that AI can be put through the ringer, facing millions of challenges without a single real tire ever touching pavement. And this right here is the secret sauce. It's not just about faking a road on a screen. It's about simulating the entire experience. The AI is literally touching virtual buttons on the dashboard. It's triggering system warnings, and then it tests the whole chain of events that happens next. And the crucial part? It does this over and over, perfectly, every single time.
Okay, so we know what ZAPTEST does, but how does it actually pull it off? Let's kind of peek behind the curtain and get inside this virtual cockpit to see how an AI can simulate a real drive to test these unbelievably complex systems.
It follows this really clever, logical process. First, the AI script pretends to be a driver, poking around the virtual dashboard, maybe setting a destination. Then, bam, it throws a curveball. It creates a virtual event, like a sudden downpour that blinds the sensors, or a digital pedestrian stepping out from behind a car. This makes sure the right safety alert pops up. But step 3 is the big one. Does the car actually execute the whole safety plan? Does that alert lead to a smooth braking maneuver or a safe lane change? And finally, the magic part. It repeats that exact scenario, flawlessly, thousands of times across every software version you can imagine.
And the end result of all this? You get an incredibly complete, rigorous, and exhaustive test of a system like Tesla's FSD, all without driving a single real-world mile. It is a total game-changer for validating safety.
So what does this all mean for the future, for actually getting autonomous cars out on our roads? Well, the impact of this AI-driven approach is just massive. And it really boils down to a few key benefits that could hit the accelerator for the entire industry.
First off, it is unbelievably fast. Scenarios that would take human drivers weeks or even months to test out on the road can be simulated in hours, sometimes even minutes. You can blast through thousands of different tests at machine speed.
Second, and this is maybe the most important thing for safety, it's perfectly repeatable. Every single little detail of the test is identical every single time. This is the only way engineers can be absolutely positive that a software update actually fixed a problem without accidentally creating a brand new one.
And that brings us to the ultimate benefit: 0. That is the number of human test drivers who have to be put in a potentially dangerous spot. The physical risk during this part of the process is just completely eliminated. And this leaves us with a pretty fascinating, maybe even unsettling final thought. When the test driver is an AI, when a machine becomes the gold standard for proving something is safe, what does that mean for the driver's seat itself? It suggests the future of this technology might be arriving a lot faster and a lot more safely than we ever imagined. And it's going to force all of us to decide when and how much we're really ready to trust it.